Okay, Assalamualaikum warahmatullahi wabarakatuh and very good day. Today I would like to share this example to how to solve this example. If you look at this solution, in this case you need to calculate the force P needed to hold the cable in the position shown so that segment CD remain horizontal and the height of YD. So if you look at this figure, we have two unknowns. The first unknown is P. Second unknown is vertical distance from D to E or YD. Okay, this cable is supported by pin support at A and pin support at E. And then they are supported at the same level. So this cable loaded with a vertical point load of 10 kilonewton at B and then 15 kilonewton at D and P at C. And horizontal distance, okay, from A to B, 6 meter, and then B to C, 9 meter, and C to D, 15 meter, and D to E, 10 meter. Okay, so in this case, you need to calculate what is value for P and what is value for YD. Okay, now we go to step 1. Remove both supports A and B. Okay, assume the segment of cable connected to that support is in tension. So we assume at support or at this segment the condition of the internal force like this in tension. So calculate the value of tension using equilibrium equation. When we talk about equilibrium equation means that we can use moment equilibrium equation, horizontal equilibrium equation, and vertical equilibrium equation. Like this, moment at E equal to 0, Fx rightward direction positive equal to 0, and vertical direction, okay, going up positive equal to 0. So we can use these three equilibriums equation in order to solve this problem. Okay, firstly, we assume moment at E equal to 0. So this one is point E. Okay, we assume moment at E equal to 0. Okay, now we move this one. Okay, let's say moment at E equal to 0. Clockwise direction is positive. So equal to, we start with, okay, for TAB is inclined load or inclined internal force. So firstly, you need to make this one as vertical. TAB sine theta 1. Okay, angle at this point is theta 1. And then for this joint theta 2 and at joint D theta 3. We assume at joint B as theta 1, at joint C as theta 2, and at joint D as theta 3. So for inclined force, firstly we make it as vertical load and horizontal load. Okay, for vertical load, TAB become TAB sine theta 1, and for horizontal load become TAB cos theta 1. Okay, so theta 1 is, alright, theta 1, okay, tangent. From this figure, we can identify value for theta 1. Okay, from this one, okay, this is theta 1. Okay, so theta 1 tangent, theta 1 equal to 8 over 6. Okay, horizontal distance from A to B is 6 meter. So theta 1 equal to tangent inverse 8 over 6. So theta 1 become 53.13 degree. So now we take note here, theta 1 is 53.13 degree. Okay, theta 1 is 53.13 degree. So, and then we move to this one, moment at E equal to 0. So, equal to, we start with 10 kilonewton. 10 kilonewton rotate anti-clockwise to point E. So, I prefer to use this color so that we can differentiate between load and also the solution. And then minus 10 kilonewton times horizontal distance from B to E. So 9 plus 15 plus 10, so 34. Okay, so 10 minus 10 times 34. And then for P, okay, so this one also anticlockwise to E, minus P times horizontal distance from from C to E, or 25 meter. Okay, negative P times 25. And then next is point load at D. The value is 15 kilonewton here. So this load will rotate anticlockwise to E. So minus 15 times 10 meter. Okay, minus 15 times 10 meter. All right, and then we look at this vertical load, or TAB sine theta 1. So this one, TAB sine theta 1. TAB is going up. This load, or this internal force, will rotate clockwise direction to A. So plus, okay, TAB sine theta 1 times distance from B to E is 110 plus 15 plus 9 become 34. Okay, plus 34. And then for TAB, cos theta 1, this one rotate in clockwise direction to E. Okay, so plus TAB, okay, I put here TAB cos theta 1 times 8 meter. Okay, so this one is equation for when we take moment or at point E equal to 0. So when we rearrange these solutions, this one become this one. Okay, so you can refer to this solution. So equal to 32 TAB. When you rearrange, you found out that, okay, 32 TAB equal to 25P plus 490 kilonewton. So we assume this one as equation 1. From this free body diagram, okay, so we can solve using horizontal equilibrium equation. So for horizontal equilibrium equation, we have TDE and TAB only. Okay, so TDE cos theta 3. Okay, TDE, okay, when you make this inclined force to horizontal direction, okay, so TDE multiply with cos theta 3 minus TAB cos theta 1. So we assume this one as equation 2. Okay, so since theta 3, theta cos theta 1 is 0 0.6, you just theta 1 is 53.13. Okay, cos 53.13 become 0 0.6 TAB equal to TDE cos theta 3. So this one become equation 2. And next is we use vertical equilibrium equation. Okay, based on this free equilibrium equation, so we can make another equations. Okay, so in this case, TAB sine theta 1, okay, for this one, and then minus TDE sine theta 3, okay, and then minus 10 kilonewton at B, minus P at C, and minus 12, minus 15 at D. So this one is 15. Okay, minus 15 kilonewton at D. So when you rearrange this equation, you can this equations, okay, 0 0.8 TAB plus TDE sine theta 3 equal to P plus 25 kilonewton. Okay, minus 10 minus 15 become plus minus 25. When you bring this one to right part, on the you bring it the other side, so become positive 25 kilonewton. And then we move to step 2. Dismember the cable and using method of section to calculate the tension force for every segment In this case, we just consider, remember, A, B, C, D. Okay, from A to D only. So from at B, TAB maintain TAB. However, for segment CD become this one. Okay, so in this case, TCD is perfectly in the horizontal directions. Okay, at the horizontal direction. So, and then we use vertical equilibrium equation, TAB sine theta 1 minus tan minus P. So this one, TAB sine theta 1 minus tan minus P. Okay, tan is going down, so that's why negative. P also going down, that's why negative. TAB is going up. So, and then TAB equal to this equation. So TAB equal to 1.25 P plus 12.5 kilo Newton. And then substitute this equation into equation 1. Okay, so equation 1 is 32 TAB equal to 25P plus 490 kilonewton. All right. So TAB, you put the value TAB into that equation, and finally you can get P is 6 kilonewton. And after you got this value, P equal to 6 kilonewton, you put this value into equation 4 so that you can determine TAB, okay, tension for segment AB. Tension for segment AB equal to 20 kilonewton. And then from equation 2, okay, this equation, 0.6 TAB equal to TDE cos theta 3. Okay, you put value TAB into equation 2. So finally, you can get this one. TDE cos theta 3 equal to 12 kilonewton. We assume as equation 5. And then from equation 3, okay, this one, okay, or we solve the free body diagram ataupun we solve the problem using vertical equilibrium equation. Okay, 0.8 TAB, you got the value TAB, you put there, and then TDE sine theta 3 equal to P plus 25 kilonewton. And then when you rearrange that equation, P is 6 kilonewton, you put that value into equation 3. So you can get this solution. Okay, so this equation TDE sine theta 3 equal to 15 kilonewton. Okay, we know that tangent theta, okay, tangent theta equal to sine theta over cos theta. So in this case, you can divide equation 6 with equation 5, or you divide equation 6 with equation 5. And finally, you can get this one. Okay, tangent theta 3 equal to 1.25. Or this one is TDE. Okay, 6. All right. TDE sine theta 3 equal to 15. Okay, divide TDE cos theta 3 equal to this one is 12. Okay, you cut this one, and then tangent theta 3 equal to 15 over 12. Okay, theta 3 equal to tangent inverse 15 over 12. So theta 3 become 38 point, theta 3 become 51.34 degree. Okay, 51.34 degree. And then YD, if you look at this one, theta 3, okay, this one is 51.34, okay, 51.34 degree. So based on this one, tangent 51.34 degree equal to YD over 10, okay, YD over 10. So YD equal to tangent 51.34 degree times 10. Finally, you can get the value is 12.5 meter. Okay, 12.5 meter. Okay, this one is how you solve or you determine vertical distance from D to E and also P value. Okay, thank you very much for your attention.